Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about 805 on-chip memories. So internal memory, how it will be classified, we can see it detailedly. Look at this. This is the actual internal memories. I already told you this is an 256, but the user can use only 128 bit. So the actual this is the upper 128 bit. This will be used for SFRs, and remaining this lower 128 bit, this is the RAM location. This will be used for applications. Look at this. So it have a general purpose registers 00 to 1FF. All the register banks comes here, and then 20 to 20F, this is then bit addressable, and then 30 to 7F, this is the direct and indirect addressing memory location. This is 80 to FF, this is an upper 128 bit RAM. There will be only indirect addressing will be used. Here only all the SFRs will be mapped with this. So only SFR have the direct addressing capacity, remaining only indirect addressing will be possible, and then locations also already fixed with the SFR registers. So this is the lower 128 bit. So it supports both direct and indirect addressings. So here it is 0x00. That indicates 0x indicates hexadecimal. So hexadecimal 00 to 1F. So this is an actual values we are taking. This is for a general purpose. And from this 20, this is a hexadecimal 20 to hexadecimal 2F. We can see detailedly. Look at this. Actually, this is we are taking only this general purpose registers. So actually, this is the size. Only this general purpose register I am expanding here. So this is total size is 0x00 to 0x1F. Look at this. This is 0x00 up to 1F. This is expanded. Look at this. What is actually inside this? So we have a 4 bank. This is a bank 0, bank 1, and bank 2, and bank 3. We already know this. We have 2 bits in the program status word, that is RS0 and RS1. That is program status word bit number 2 and bit number 3. So these 2 bit will be used to select any one bank, but at a time only one bank can be chosen. Look at this. The registered bank R0 to R7. So this will be mapped here. If I selected bank 0, the R0 indicates the address location 00. That means whenever I am moving the data to R0, or whenever I am accessing the data in R0, it automatically accesses the 00 location. Similarly, whatever I am storing that, the corresponding locations will be stored. So R0 for 00, R1 for R1. Similarly, R7 it is for a 07. So R0 to R7 will be mapped to 00 to 07 if we selected as a bank 0. If the user select bank 1, what happened? The same R0 to R7 will be mapped with this location. So if I select with the bank 1, if I store some data to R0, what happens? It will be stored in 08 location, not in 00 location, because I selected as a bank 1. So depending upon that bank selection, this R0 to R7 will be mapped with this 00 to 07, or a 08 to 0F, or a 10 to 17, or 18 to 1F. Depends on this bank selection. So whenever we are selecting bank 0 and storing some data, after that we are selecting bank 1 and restoring that data, what happens? The previous data will be not erased and it retains. So what happens? If we need to retain the previous data, we can shift from one bank to another bank. But it is not possible to use both banks at a time. So for example, I have some important information in this R0 to R7 register. I need to use this register without affecting the data. I simply jump from bank 0 to bank 1 or bank 2. There whatever I use, that particular locations only used, these data cannot be erased. So it will be retained that data is present in bank 0. Look at this bank 2. So this is from 10 to 17. So if I store data R0 in bank 2, this 10 will be used. Look at this. This is a bank 3. For example, if I select a bank 3 and if I store some data to R7, what happens? This data will be stored in 1F. So this 18 to 17. This is 18 is for R0, 19 for an R1. Similarly, the increments up to 1F, that will be R7 will be stored. Look at this next one. So this is the general purpose register we have seen. Now we are going to see this bit addressable location. So bit addressable location is range from 20 to 2F. Look at this. This is a 20, 21, 22, 23 up to 2F. This is the actual locations. So this is the actual addresses. Each location consists of 8 bits. So normally we store 8-bit data in each location. Here I use this byte address. This is a byte address. Each location can be accessed with the byte address. Similarly, I can access with the bit address also. So for example, if you take this byte address 20, this location consists of 8 bits. Each bit will be accessed with the bit address of 00, 01, 02. This is the actual bit address. So 002, 07. Similarly, 21 location 8 bits from 08 to 0F. If you go with 22 location, it comes from 10 to 17. If you go with the next location, it comes from 18 to 1F. If we go with the 24 location, what happens? So this is a 20 to 27. Next will be 28 to 2F. Like that it increments. So the address for a 2F, this is the maximum location. It will be taken as a 78 to 7F. So if I want to access particular location, for example, if I access this location, if I want entire location, I can use this byte address 20 and I can access all the 8-bit information. Instead, I can need to access only this location. I can use bit address, I can use 00. So we have two addresses. If you want to access a 1-bit information, I can use a bit address. If I want to access all the 8-bit data, we can use a byte address. So whatever the data storing with the byte or a bit, it contains the same location. We can, for example, if we want to extract some bits from a byte, we can use this method of storing that with the byte address and accessing with the bit address also. So look at this. For example, 20 to 2F, this is 16 location. Each location will be 8 bits. So 16 into 8, that will be 128 bits. So bit addressing instructions, look at this, move C, 1A. That means the carry flag will be moved with 1A locations. So 1A bit addressable location data will be moved to this. So this is equivalent to, look at this, actually this 1A comes in this 23 locations. So this is the actual 1A. How it means, so here comes from 18, next 19, this is 1A, 1B, 13. So if the data says, this is the 1A now. So move C, 1A is equal to move C. This is the 20th byte now. So 25th byte. This is the bit 0, bit 1, bit 2. So move C 23H dot 2. So that means 23 the location. Second bit data is moving to C. So both will be same meaning. Thank you.